Hello everyone, this side Curve. In this video, I'm going to explain the logic I have used in my pseudocodes, and I'm going to provide a detailed explanation about the part D, which is Dijkstra algorithms. I'll mainly focus on how many algorithms I have used and I have worked on it. So I'm going to explain 5 steps of Dijkstra in detail. First is the step number A, which is the number of shortest paths from train station. Mm, first I have first I have first I am going to explain the part A. In this part I have used the breadth search first search, also known as BFS in short, because every edge has equal weights and BFS explore all nodes and level by level. So the first time we reach a node, we know that we found its shortest distance. Here I created two arrays. The first is distance S, which stores the shortest distance from the source node to every other node. The second is path S, which mainly store the number of shortest paths. Next, I am going to initialize all the nodes. Distance start as infinity because they have not been visited, and the path count start at 0. Then I set the source node distance to 0 and path count to 1. Then I create a queue, insert the source node. The algorithm repeatedly removes one node from the queue and checks all neighboring nodes. If a node is visited for the first time, I update the distance and copy the path count. If another shortest road with the same distance is discovered, I'm going to increase the path count for that. Now we're going to move to the part B and the part F for the algorithms. Part B is mainly we're going to check the network is connected or not. For the part B, I again use BFS, but here the objectives is quite different. I start from one computer or node. I'm going to visit all reachable nodes. If every node became visited, then the graph is connected. Otherwise, if some nodes remain unvisited, then the network is disconnected. Now we're going to move to the part F, which is also a part of the Dijkstra algorithm uh, that we have to focus mainly on that. That is negative cycle path check. For part F, I use BFS or I use DFS two times. And first I start from source node S and determine all the reachable nodes in it. Then I reverse all the graph edges and run the search again from the destination T. If the negative recycle can be reached from the source S, can also reach destination T, then a negative course path will exit in that particular scenario. Now we're going to move to the Dijkstra table that we have made for that task particularly. Here is the Dijkstra algorithm table. This algorithm's table works by selecting the node with the smallest temporary distance value and updating neighboring nodes. Initially, node 1 is assigned distance 0 because it is a starting node. Every other node is assigned infinity. So in step 1, I start from node 1 with cost 0. Node 1 connects to node 2 with cost 4 and node 6 with cost 10. So the temporary values became node 2 equals to node 4, node 6 equals to node 2 equals 4 and node 6 equals 10. Node 2 has a smaller cost, therefore node 2 is selected next. So we are going to move to the node 2 row. Now I'm going to process with node 2 with cost 4. Node 2 update several neighboring nodes. Node 4 becomes 9, node 5 becomes 15, node 7 becomes 12, node 8 becomes 14. Among this value, node 4 has the smallest cost. So we're going to move forward with node 4 now. Next I select node 4 with cost 9. Node 4 updates node 3. Node 3 node 3 will become 11. Node 6 is also checked by node 6. Node 6 already has a smaller cost of 10, so the node 6 is not updated in this particular scenario. Now we're going to move to the node 6. Now node 6 points back to node 4. New cost became 13, but node 4 already has cost 9, so no particular updation required. Now we're going to point node 3. Node 3 connects to node 5. Node new cost becomes 20, but node 5 already has a smaller value of 15, so again no updation is required. At the end you can see, so the first selected 5 nodes are node 1, 2, 4, 6 and 3. The algorithm continues in the same way until all the reachable nodes have been processed and the shortest path state generated. That's all we have to discuss for this particular scenario and for this particular algorithms and for this particular task. Thanks a lot.